Today we're going to talk about arithmetic sequences, and so there are a few vocabulary words that we need to talk about before we get to those. So a sequence is a number pattern, something that's happening where a pattern is happening with numbers. So it could be that the numbers are being added or subtracted or multiplied, divided, something, but there's some sort of pattern happening to it. The term is each individual number in a sequence. So if you have 1, 7, 13, like 1 is a term, 7 is a term, 13 is a term. An arithmetic sequence is where you're going to be adding a fixed number to each previous term, right? Adding a fixed number to each previous term. And the common difference is that fixed number that's being added. So using these vocabulary words, we're going to put them to practice in a few different types of examples here. So the first example that we're going to deal with is we're finding the common difference. So we're going to determine if the sequence is arithmetic. And if it's not arithmetic, then there is no common difference. If it is, we're going to state the common difference and find the next three terms. Okay, so the first one we have here, our sequence is -7, -3, 1, and 5. We have to see what's happening here. So to get from -7 to -3, we're getting bigger, so we're adding 4. From -3 to +1 is adding 4. And from 1 to 5 is adding 4. So since we're doing the exact same thing every single time, this is arithmetic. Now, it says to find the common difference. The common difference is that thing that you are adding each time. So, and we're going to use the letter D for that. Our common difference is a +4 because that's what we added each time. Then we need to find the next three terms. Well, how would we do that? If we're adding 4 each time, we're going to take a +5, and we're going to add 4 to it, and we would get 9. And then we would add another 4. What number would we come up with? So we have 9. The next one would be 13. After that, we would add 4 again and get 17. So the next three terms in the sequence would be 9, 13, 17. Those three pieces make our answer for this question. All right, let's take a look at another one. So we have 8, 3, -2, -7. So here we're going to figure out what pattern is happening, or if there is a pattern. So from 8 to 3, we're getting smaller. So we're going to be adding a -5. Okay? Or just subtracting 5. From 3 to -2, again, we're subtracting 5. And from -2 to -7, we're subtracting 5, or adding a -5. So, since the same thing's happening each time, we would say arithmetic. Our common difference is whatever we just did each time. It's got to be consistent. It's called a common difference, so it needs to be common between all of them. And then we need our next three terms. So we're at -7. We need to add a -5 or subtract 5, which would give us -12. We would subtract a 5 again and get -17. And one last time, because we need three terms, would be -22. So those would be the next three terms in this sequence. All right, last one here. We have 1, 2, 4, and 7. So to go from 1 to 2, we're adding 1. From 2 to 4, we're adding 2. From 4 to 7 is adding 3. Is that arithmetic? Did we do the same thing every single time? So no, there's a pattern. Add 1, add 2, add 3. The next thing would add 4. That's a pattern. It's a sequence, but it's not arithmetic. In order to be arithmetic, you have to add the same thing every single time. And that is not what we did here. All right, let's delve a little bit deeper here into arithmetic sequences. Let's look at the recursive formula for this, okay? And so we have a of n, that's the nth term that we're dealing with, equals a, which is the first term, plus n minus 1, this is the term number that we're on, times the common difference. And you can also see this where the common difference is out front of those parentheses. So a of n equals a plus d times n minus 1. It's the same thing. It's fine if you want to put the common difference in front of the parentheses or behind the parentheses. It doesn't matter. Okay, but we need to know what these things stand for so that we're able to build equations. Okay, so n is what term number we're dealing with. We need this n minus 1 piece here because for a recursive formula like this, we need the previous term to then multiply by that common difference before we add it to whatever we had before it. Okay, so using this information, we're going to figure out some other stuff. Now, actually, before we go back here, another way you can see this as well, you can see this as a sub n equals a sub 1 plus your common difference times n minus 1. So that's allowed to happen. This is just a different notation. A of n or a sub n is still standing for the nth term. A or a sub 1 still standing for the first term. So you can see those things as well. All right, so let's put this into some practice. We're going to find the function rule. We're going to be given the sequence, and we're going to determine what the actual function rule for it is, knowing that or figuring out first if it is arithmetic, because if it's not arithmetic, then we can't do this. Okay, so we have 7, 11, 15, and 19, and we're going to find the function rule. And these are kind of things that we need. We need to know what is the first term, what is the term number, and then what is the common difference. Those things come together to build this equation. So first term is 7, because that's the first term that was given to us. Let's see what's happening here. To go from 7 to 11, we add 4. 11 to 15, we add 4. 15 to 19, we add 4. So our common difference here is a positive 4. And the term number is just going to be n. Okay? So our general formula for this would be a of n equals the first term, which was 7, plus our common difference times n minus 1. Or you could also see this as a of n equals 7 plus n minus 1 times 4, where the 4 is behind it. It might be more natural for you to see it in this nature here. So this is the function rule, but either of those would be acceptable answers. All right, let's take this one step further, where we are going to find particular terms of a sequence. Okay, so we're given this sequence, and we're going to find the first, fifth, and 10th terms. And it's not always going to be the first, fifth, and 10th terms. It's going to depend on the question and what they're asking you. Okay, but we have this function rule, a of n equals 12 plus n minus 1 times a negative 2. So for the first term, that is telling us that we have an n value of 1. Now, we should be able to tell the first term just by looking at this equation and knowing what the different pieces are. So we should know that our first term is this right here. But let's algebraically prove it. So we're finding a of 1 because n equals 1 for the first term. And that means that we're going to substitute 1 in for n and then do the calculations. So here we need to do the parentheses part first. 1 minus 1 is 0. 0 times negative 2 is 0. And 12 plus 0 is 12. So 12 is our first term. And we already knew that from that information. Now obviously for these you could sit there and count using the common difference of negative 2. But especially as you get into bigger terms, you're not going to want to do that. So we're going to want to be able to plug these values in. So the fifth term, this now means that n is going to equal 5. So we're going to substitute in 5 for n. And then we're going to do the calculations for that. 5 minus 1 is 4. 4 times negative 2 is negative 8. 12 plus a negative 8, or 12 minus 8, would mean that the fifth term is 4. And you could have gotten that by taking 12 and then counting -2 back each time until you got to the fifth term. Last one here is the 10th term, which means that now n is going to equal 10. So we're substituting that in. And then we're going to perform those operations. So 10 minus 1 is 9. 9 times -2 is -18. 12 plus a -18, or 12 minus 18, is a -6. And so that's going to be our 10th term. So with these, we just need to remember this formula, and it has, a few different ways that you could write this, but n is the term number, d is the common difference, and a is going to be your first term. A of n or a sub n is the nth term, or whatever term you're looking for in this sequence.